All right, so we've used infinity already, so we're just kind of formalizing it a little bit. If a function grows without bound, either positively or negatively, we call this an infinite limit, and it equals positive or negative infinity, depending on which one. While a function will never take on the value of plus or minus infinity, a limit can. And this is an important point to make here. So if you have let's use like a basic rational function here. So for instance, if you take like the limit of this function, it looks all squirrely, as x goes to, let's say, 2 from the right of 1 over x plus minus 2, then that would be positive infinity. But you would never actually want to say that f of 2 equals infinity. Now, when you write that, it's not just, mathematicians being finicky about things, which they certainly can be. But when you write that, what you're saying is that your y value is equal to infinity. And a function never takes on infinite values. Like f of 2 cannot equal infinity, but the limit as x goes to 2 can certainly equal infinity. Now, if you are really hard set on wanting to have function values equal infinity, good. Take some more math, get up to real analysis, and then you can plug in infinity. It's a lot of fun. But for right now, for our purposes, this is what we've got. All right. So let's talk a little bit about these infinite limits. So for this one, we're talking about the general limit as x goes to 3. So if you notice on our graph here, it's already notated here. So as x goes to 3 from the right, then that limit is infinite. And that is because as we are moving along our function, as x goes to 3 from the right, then this graph right here is just going up towards infinity. Now, as x goes to 3 from the left, the graph is actually dipping downwards like that. It's going to negative infinity. So infinity is not necessarily bad. It just means if you have two different types of infinity, then we can't really do much with that in terms of a general limit. I mean, we're going to two very different places. This one's going up, and this one is going down. So we can't really say too much about what the general limit might be. So general limit at 3 does not exist. Now, another thing that we can do, and this is kind of a conceptual shift, is we can actually take x to infinity. So we've looked at a few situations where our limit is equal to infinity, but a limit at infinity means what we're doing is we're taking larger and larger values of x, or negative and more negative values of x, and plugging them into our function. So we can do that, but it's not quite as cut and dry as before when we were taking a limit as x goes to a number, because we can't just take infinity and stick it into an equation and say, okay, my limit is infinity squared minus 2 infinity. That doesn't mean anything. So we really have to be more methodical about how we move forward with these. Now, in your prerequisite courses, this was referred to as in-behavior. And in those courses, us math teachers didn't want to put a lot of extra dressing on it. But this is really a limit at infinity. You're talking about the behavior of the graph as you move really far off to the right or really far to the left. You're looking at whether your function flattens out. That would be called a horizontal asymptote, or whether or not your function kind of shoots off and goes to infinity as well. So let's take a look and see. All right, so remember, if we've got a graph, the best we can do is use the graph to kind of make a educated determination, not an educated guess, about what the function is doing. So it looks like as x is going to infinity, what does that mean? So that means we are going on the function and we're saying, okay, we're taking our x this way. What is my function doing? So it looks like our function is flattening out right here at 0. So as x goes to infinity, we would say that the limit of f of x would be 0. Now, from this side, from the other side, so as x goes to negative infinity, remember, we're taking x to negative infinity. So even though this is going to negative infinity, but that's the function going to negative infinity. This is talking about taking x to negative infinity and figuring out what the function does. So again, this is the function going to negative infinity. X going to negative infinity means we're taking x and we're taking it just further and further out to the left. And from what we can tell on the graph, it looks like that flattens out to 0 as well.